Rest in peace. Here's another warrior song. Rep this life to the fullest.
Welcome to Defcon 32. Four Thieves Vinegar Collective is having a great time. We just did 2 talks on eradicating hepatitis C with bioterrorism. You're going to see some clips. You're going to see some of our friends. We had a great time here. Stay tuned.
Today we got Michael. He's going to join us to give us talk. As is tradition, it is Michael's first DEFCON talk.
Oh.
So, for those that don't know, there's a tradition where you have a shot of your alcohol of choice on stage. We did have to have a goon meeting last night where we clarified it's shot the noob, not shoot the noob. Because some people were confused about the actual mechanics of the situation. It's shot the noob. So we're going to give Michael a shot of his alcohol of choice, which is vodka. So if everyone could cheer Michael on while he has his new shot of vodka. Perfect. All right, and with that, Michael's going to talk to you about eradicating hepatitis C with bioterrorism. So one more round of applause for Michael.
I don't know who needs to hear this, but I'm scared too. All the time. Of losing the health that I have. I know what it feels like. I know what it feels like to not know what's wrong with your body and to have to go shop for a stranger who has the authority to maybe or maybe not give you what you need. I know what it feels like to know what's wrong with your body and to know what you need and to be told you can't have it because the infrastructure has failed and it's not available. I know what it feels like to be told that you can't get it because it's not legal in the place where you are. I know what it feels like to be told that you can't have it because the doctor doesn't share your opinion. And perhaps worst of all, I know what it's like to be told you can have it only to realize that you can't afford it. I know this happened to you. It never should have occurred. This is wrong. And I hope to show you all some tools so that it doesn't ever have to happen again. The photograph you're about to see, you'll notice I looked different then. I had long hair. I was overseas. 3 days later, I had no hair anywhere on my body. And 3 weeks later, I had all new skin. And I decided to be magnanimous and not show you how it came off. But it was rough and it was ugly. Then there's another picture. I'm recovering in a hospital. I have an IV in my hand. A tumor had just been removed from my body that was invisible on the MRI. And the only reason it got removed is because I insisted on it. There's another picture of me recovering in the same hospital because I had to have another operation, also under general anesthesia, just to prepare for the other surgery. The important thing to note, and what I'm trying to impart here, is that most medications you can make a better, cheaper version of yourself at home. Anybody can. There are a handful of tools that you need to go through this. The first thing that you need to do is you need some chemistry. Now, most people kind of cower. Chemistry seems hard. It seems like a specialized thing. Well, sure, if you're doing research chemistry, yeah, that's why there's a PhD in it. Of course. But if you just need to operate it, similar to the difference between building a computer and using a computer, it's significantly easier. It says a lot about the state of humanity when we develop all of these things and don't deliver them. Sorry, I just got to bounce back to this slide too. This is so important. Those research chemists that are doing biochemistry, they're doing medicine, they're doing incredibly important things. It's amazing. It's amazing. It's so sophisticated. And yeah, there's a reason that they get PhDs in it. But if all you're trying to do is pirate something, that's doable and it can be automated. I believe this. That's why I'm here. Hacking is important for the world. It saves lives. All of you know this. You've seen it. This is just a little more direct. It can happen with anything. You take something and you use it for a purpose for which it was not intended, so that you are no longer gatekept against access. This is why we do what we do, and I know you all understand this.
Yeah.
Knowledge belongs to all of humanity. I believe this with every fiber of my being. There have been moments in history where economics and morality have come to a head, and the economists have said, you can't have that. I'm sorry, it's not moral. It's the way our economy works. And the moralists have come back and said, that's not good enough. It happened in this country with slavery. People said, people can't be property. That is not acceptable. And the economists said, yes, it's really unfortunate and it's kind of old, but that's how our economy runs. And the moralists came back and said, that's not good enough. And similarly today, people are dying every day because of intellectual property law, making it so that people do not have access to the medicines they need. And the economists say, oh, I know it's an old system. I know it's being abused. It's kind of unfortunate, but there are trillions of dollars circling the world. We can't just pull the rug out from under that. And there are some of us who are saying, that's not good enough. I know you all believe in the right to repair. I do too. I believe in the right to repair for your body. And this is not a new idea. It used to be that everybody was involved in their own health. The notion that you can't manage your own health is fairly new. Gates have been put up saying, you can't do this. You're practicing medicine without a license. You're not allowed. But if you come to the authority, we'll sell it back to you. Not acceptable. You need to become involved in your own health. You can't just follow doctor's orders. It's not good enough anymore. I don't know if it ever was. We know that this is not an excuse in wartime. Why is it still an excuse when you're dealing with your health? It shouldn't be. I'm going to say this again. You can make most medicines yourself at home, and you can make them better. I'm not kidding. Better and cheaper. Now, we're going to have to look at how. I want to do a quick poll here. How many people know somebody who owns a cat who is also either immunocompromised or pregnant? Show of hands real quick. Yeah? Okay, a couple. Next. How many people know somebody who has an allergy that sends them into anaphylactic shock? Oh yeah, plenty. Okay, cool. How many people know somebody who has hepatitis C? All right, couple. All right, I'm gonna remember you. How many people have a uterus and are child-free by choice? Cool. All right. Fewer than I thought, but all right. Who remembers this guy? This is Martin Shkreli. And what you're seeing right now is him lying to Congress. He was CEO of Turing Pharmaceuticals. And what he was lying about was the pricing structure of Daraprim, pyrimethamine, an anti-toxoplasmosis drug. It had been $13.50 a pill. And he changed the price to $750 a pill. If you calculate this out, a full course of treatment is just south of $19,000. This is his phone number. I called him from stage at Hope in 2016. He didn't answer, but he called me back a few hours later. Of course, he got hauled off to prison a while after that. Here's what we did. We took exception to this. We found a new synthesis pathway. It had one step fewer, it was much more efficient, there were greater margins of error, and there was greater purity and yield. So we made some. Here I am at that same conference throwing pills to the audience that cost me $0.25 to make each. And you can make these things too. Making pills is easy. If you have active pharmaceutical ingredient, just pack it into caplets. Measure it out. Everybody can do this. It's not difficult. And here's what a course of treatment looks like. Now, it's amazing there was so much outrage around what he did. And yet, the pricing structure still has not changed. But you can make a full course of treatment for $80. Now, who said they knew somebody who had a cat and was pregnant? You want it? I'll toss it out. Keep that person healthy. Keep that person safe. More to come. This is Heather Bresch. She is, can you guess, lying to Congress. She was CEO of Mylan Pharmaceuticals, and she was lying about the pricing structure of the EpiPen. I know everybody remembers this one. It was $60 for a pair. And then she decided it was going to be $604 for a pair. We presented about this in 2018, and I called her at this number. It might still work. You can try it. She didn't answer. We decided to make our own version. It's not a complicated thing. You take an auto-injector that's designed for needle-phobic diabetics, you put in a small syringe, a large needle, and a vial of epinephrine. You can make one too. This costs $30. Additionally, you can test it to see if it works, and you can reload it for $3. You just need a new needle, a new syringe, and a new hit of epi. And again, after all of this time, the pricing structure has not shifted. There is no leverage to change these prices. You can make your own. It's not hard. Now, who said they had a friend who had anaphylactic shock? You want it? All right, here, pass it back. Keep that person healthy. Keep that person safe. And make more. It's not hard. And then there was the time that these 9 robed creeps decided they were going to ruin... Sorry, hang on. And then there was this time that these 9 robed creeps decided they were going to just ruin everything for everyone by saying you couldn't have the medicine you wanted if you happened to have a uterus. We thought this wasn't cool either. And I hope in 2022, we figured out a way to dope business cards with abortion drugs. It's fairly simple, and you can do it too. Here's all you need. You get some active pharmaceutical ingredients, some Everclear, a blender, and a pipette. Then all you do is you put in the Everclear, you put in the powder, you blend it up, and then you take the pipette and you put 6 dots on a business card. Here I am 2 years ago at Defcon, at a house not far from here, making about 200 on a table. Here's all you do. You lay them out. That top one's special edition. You can't get that anymore. You put 6 dollops on a card. Those are the 3 doses that you need to induce an abortion. You let it dry. It curls up like this, and then you put it in a baggie. It is super simple. Here's the entire table, and then you bag them up in the morning. And then maybe you put them places. Because it's just the size of a card, maybe in the family planning section, in a drugstore. Or maybe at your local public library, you find an appropriate volume that somebody who might be in need might find, and you just slip it in there. And again, the recipe you just saw is for 100 cards. So Maybe you even get really creative and decide that another third place that people go to who might have trouble getting access to these sorts of things. I mean, up to you. The Guttmacher Institute estimates that it's about $500 if you want an abortion through traditional channels. If you send away for mifepristone and misoprostol pills, it will cost you about $160. These cards, they cost 89 cents to make, including the printing of the cards and the baggies. You can afford to make these. And despite all the outrage around all of it, this pricing structure and the access hasn't shifted much. Now, for some of you who recognize patterns, we'll anticipate the next question, which is, who would like my business card? Who wants this? I'm not gonna make assumptions, but I think you don't have a uterus. Which, yeah, all right. Here, will you pass that back? And there may or may not be a bunch of these stashed in ladies' rooms around. I don't know who put them there. This is hepatitis C. This is what we're talking about today. This is terrifying, and it's not common knowledge. It is more virulent than HIV, it is more widespread than HIV, and it is more lethal than HIV. And it is a very clever virus. If you want to get into the molecular biology of it, it's incredible. It is awe-inspiring. This is svaldi, also known as sofosbuvir. This molecule makes magic happen. It actually goes in and interdicts in the replication process when hepatitis C is trying to make more of it. Here is the enzyme that allows hepatitis C to make more by replicating RNA. And here is svaldi inside of the binding pocket doing what one of our chemists referred to as fucking shit up. This is not just a drug that's helpful. This drug will actually eradicate the virus from your body. This is the first time this has ever been done. If you have a virus, either your body manages it or you have to continuously take antivirals for the rest of your life. You can actually be hepatitis C free with this drug. It's not just a treatment. You take 1 pill a day for 12 weeks, and hepatitis C is gone from your body. What is the catch? These pills cost $1,000 a piece. And for those of you who are good with arithmetic, you will notice that this is $84,000 that it costs. And it will come as no surprise to the Americans in the audience that insurance companies aren't super hot to pay for it. Let's look at how shitty hepatitis is. This is how it's gone the last few years. 2 seminal moments I'd like to point out. Here's where svaldi was invented. Now, those of you who are familiar with the American medical system and how drugs go will know that it takes a while between invention and approval, and indeed it did. But here's where it was approved. Maybe you noticed something kind of strange about the graph. Let's extend the data just a little bit, and you'll see, taking it up to the current day, it's getting worse, not better. That's worth wondering about. Now, as some of you know, I'm a mathematician. I will not require any of you to do the integral to calculate the area under the curve here as to how many people died since it was invented. It was over 5 million between the invention of svaldi and today, all of which could have been avoided if they had merely been given this course of treatment. And I take great exception to that. Right now, Almost 1% of the entire world has hepatitis C. It's closer to 0.75%, but look around this room and do a quick back of the envelope. There are plenty of people right here who have it. Plenty unknowingly. Again, it is more virulent and more deadly than HIV. 1.5 million people will get it this year. Some probably later today if they get lucky. Hopefully it's fun in the process. Over 250,000 people will die of hepatitis C this year. 250,000. And somebody dies every 2 minutes. How long have I been up here? When I talked about this 5 years ago, it was every 3 minutes. So again, not only is it getting worse, but it's getting worse faster. Now, usually when I start throwing these sorts of numbers out, people get a little depressed. And they ask, is there no hope? And I would like to quote one of my favorite superheroes. Oh, I will give you hope. And I ask only one thing in return. Now, you might not recognize this man, but his name is Daniel O'Day. Interesting last name to be talking about at a hacker conference. You figure somebody's gonna fuck with him, right? He is, as you might guess, lying to Congress. He is CEO of Gilead Pharmaceuticals, and he is lying about the pricing structure of svaldi, which, as mentioned previously, is $1,000 a pill and is $84,000 for a full course of treatment. And I think I have time to take exception to his pricing structure. And my hacker friends, I have a question for you. Should I call him? All right, now don't everybody call him at once, he'll jam the line. We'll see what he has to say. All right, Danny boy. Pipes are calling. Four Thieves Vinegar is calling. And we're not pleased with what you've done. So here you go. Call him afterwards if he doesn't answer, okay? Let's give this a try. Can you hear this? Can you hear this?
Hello?
Hi there, Daniel O'Day, please.
Who's calling?
This is Dr. Mixæl Laufer.
Who?
Dr. Mixæl Laufer from the Four Thieves Vinegar Collective, please.
From the what? Sorry, I can't understand what you're saying.
I'm sorry, the connection is bad. Dr. Mixæl Laufer, I'm calling from Four Thieves. He's expecting my call.
He's expecting your call?
Yeah.
Okay, hold on a second.
Thank you so much.
What?
Yep, I'm still here.
Hold on. Hold on. Dan? Dan? I still can't understand who you are. I'm sorry, can you say that again?
Yeah, Dr. Mixæl Laufer from the Four Thieves Vinegar Collective. I'm calling from Las Vegas.
I don't know. I don't think he's expecting your call.
Well, can you put me on with him anyway?
I don't know. I think so.
Who's this?
Hi there, it's Dr. Mixæl Laufer. I'm calling from the Four Thieves Vinegar Collective.
No, this isn't your call. I don't know how you got this number, but please don't call it again.
Well, you sure you don't want to chat? Hello? Well, I tried. I was gonna invite him down and everything. All right, moving on. How do you do DIY pharmaceuticals? We need to get back to the how. I've talked a lot about why, but there are tools that we have specifically that will help you through the entire process. At the top is the automation of the chemistry, and we have a tool for that, an actual way that you can automate the chemistry. Below that, there's a system that will build the instruction set that the automation system will run. Before that, you actually need to figure out how the synthesis is done. You need to figure out how to start with some material and then work your way to your end product. And we have a tool for that as well. And of course, somewhere along the line, you have to figure out what you want to take for what's wrong. If you're trying to do pharmaceuticals DIY, there are a number of pieces that have to happen. The first thing is you have to actually do the chemistry. And the micro lab, which you see being built next to me here, is the system that we've developed for helping that process and making it more automated. What that allows for is that somebody who's not super comfortable with chemistry can still participate. A lot of people look at that sort of thing and get really nervous really fast. Yesterday, I think I likened it to the difference between building a computer versus using a computer. If you're not looking to become a chemist, but you're looking to utilize chemistry somehow to do something, the skill set that you have to acquire is much less. And if you have an automated system that can help you through the hard parts and talk you through the easy parts, then you can do that. Antecedent to that, you need to be able to write the programs that the hardware will actually run. This is the recipe press, which you'll also see. And this allows you to stack a procedure together and get code into the machine so that it can execute the procedures that you want to do. Antecedent to that, you need to figure out what sort of chemistry you're doing. You need to do what's called retrosynthesis. How do you start with a starting material and then work your way from point A to point B? And of course, before that, somewhere you have to actually figure out how you're addressing your health and what you want as a drug that you want to take. So let's take a quick look at each of these. Here's how it kind of stacks together. This is a flow chart that was sort of put together. You want to, again, figure out what is wrong in a medical sense. That's your first bar there. Then you need to figure out what the active pharmaceutical ingredient. I know all of you hackers think of something very different when we say API, but API also stands for active pharmaceutical ingredient. Then you develop the synthesis pathway, you get a procedure for it, and then you develop a file that the machine will run. You run the machine, and then again at the end, you have to actually turn your active pharmaceutical ingredient into something that you can take. If it's just a white powder, I mean, some people might want to just snort it, but like better if you put it in a pill, or maybe you put it into some sort of solution that becomes an IV drip. Eventually you have to compound it some way. So let's look at the automated chemistry. Again, chemical automation is not a new idea. These are available commercially, but it's closed source. All the problems that come with that, of course. On top of that, they're ridiculously expensive. $5,000, I think, for like the cheapest, jankiest model, which is the one you're looking at. You can't even buy them if you want to pay $5,000 because they're only sold to labs. And, you know, on top of that, they aren't modular, they don't expand. So if you want something that does something else, you need to buy the next model up. You can't just put a new module in. And at the end of the day, they don't work very well. But you can see they're not terribly complicated. There's an inner chamber. You can see this blue fluid there. There's a little Teflon paddle that stirs. Outside, there's a jacket, and that is circulating a fluid that maintains the temperature of the reaction. And on top, there is something injecting reagents. So we don't like all of these poor features of the commercial version. So here's our version. Again, you can see it right over here. And if you'll note, they're not that much different because functionally they're doing the same thing. You got something that stirs, that's that inner chamber, also with a blue fluid. There's a Teflon little paddle that spins. You've got an outer jar. Both of these are just mason jars. The outer jar has a circulating fluid, and that circulating fluid maintains the temperature. And on the top, you have peristaltic pumps, which pull from those syringes to inject reagents. And then there's a little box next to it, and that is the brain that executes all of these commands. So let's see if we can take a look at all the bits and pieces of this. This, of course, is entirely open source. You can build it yourself. In fact, that's the only way you can get it. The documentation team did a phenomenal job, and you will get a wonderful walkthrough if you decide to visit our GitHub. Remember, documentation or it's not a project. You can make this whole thing for $300. Probably less for most of you because you'll have a lot of this stuff lying around. And if you're not the sort of person who feels terribly handy, you don't have to worry about it. Everything either snaps together or is screw connectors. This is not like a fancy, difficult project where you're gonna have to do surface mount rework or anything. Also, there are open ports. You can reconfigure this. If you want other things to happen, you want to control atmosphere, or you want pressure, or you want feedback from a pH meter, all of these things can be done because it's hackable. Because if you can't rebuild it, you don't own it. So let's look at all the bits and pieces here. Oh, right, and actually it works. All right, let's take a look. So this is the wonderful logo and tagline for the Microlab. This was an off-the-cuff statement, but I thought we should stick with it. Now the Microlab itself is broken down into an architecture. All of you who are the more technical will recognize these bits and pieces. These I will be able to speak to a little bit, but they were all built by people who are more skilled at these things than I am. But if you can look, it's not terribly sclerotic, but there are a lot of different things that are happening. Here's the machine itself, and again, you're looking at one of them to the left. And let's look at the pieces. So you have the reaction chamber itself. This is 2 mason jars, one which sits within the other. And there's a 3D printed armature. We call it the reactor core, which allows these to screw together so that the inner jar floats while the outer jar can have the circulating fluid. This is what it looks like if you can't see super well. That piece that you see in the top, that is the motor that runs the stirring paddle in the bottom. Here's the actual core, and it comes in 3 pieces and breaks apart like this. Snaps together very nicely, easy to construct. Now, if you look at the rest of the armature here, that purple box houses both the circulation pumps for hot and cold fluid. It also holds the peristaltic pumps which pull from the syringes. And then there's this armature that holds it all together. Again, this is what it looks like if you can't see super close. Let's take a look at the armature real quick. Now, for those of you who are mechanical engineering inclined, you'll notice that it's asymmetric. And you might ask the question, well, why would that be? That doesn't make a whole lot of sense. Was that intentional? And yes, it was intentional. Because our designers are awesome. So now that we remember why we're here, let's put it back together. And let's take a quick look at the brain. Now, the brain here is, again, 3D printed outside. Top pops off, and you can see the bits and pieces under the hood here. This is a version with an acrylic top. Again, if you're close up or you come up later, you'll be able to actually see it. It's sitting right here. And you can see that, there's a bunch of wires, but it's not too much to deal with. And we can take a look at each of these individual pieces. So here again, you can see how it's wired. It's not too terribly much, and a lot of these are already ported. The connectors at the top you'll see are screw terminals, and these allow us to connect the brain unit to the armature itself. You have a relay board. There's an Arduino that controls the pumps. The main brain is a Raspberry Pi, and then there's an interface that is this touch screen. These are really slick connectors, and it makes it so that you can take it apart. And maybe you noticed Vinny over here who managed to put this together in 10 minutes just from bringing it in cases. This is a really easy system to use. And thank you, Vinny, wherever you are. So here you can see kind of how it's broken out. You've got these nice little snap-togethers. The relay board, again, controls a number of things. There is a PID module that regulates temperature, and so you've got a heating element that's going to kick on or off as it predicts the curve of temperature as it moves, try and smooth out transitions. Additionally, you've got something that turns the stir motor on and off. And also it's expandable. There are a few other things that you can do. I think we had a light on one of the earlier ones. Would have been nice in this room with the mood lighting. But, and then again, the systems run on either 5 or 12 volts, and there's a little controller in there. You can see also here, this is an Arduino Uno, and the CNC shield, that, I believe I said this already, but that controls the pumps. So those are essentially just stepper motors. And so it's pretty simple to have a G-code interpreter just send commands to say, turn it this much. And one of the things that's important about this is that when you're doing chemistry, most steps in most procedures for doing synthesis say, add this amount of this thing, this quickly or slowly, then bring it to this temperature and stir it for this long. And so one of these things that it allows us to do is a recent update that's really great. You can say, add this over this amount of time. And this allows for a lot more things to be done. So looking at the bits and pieces, here's how they float. You can see again, the touch screen snaps into the Raspberry Pi. On the other side, you can see the Arduino that has the CNC hat on it. The bottom piece is the voltage regulator, and the top is the relay control. And again, you don't have to build it like this. One of the things that's wonderful is that this is reconfigurable. If you don't like it flat and you want a tower instead, you can totally do it. The relay board, you can actually even snap in between the Raspberry Pi and the screen if you want, but you have to have a taller box. So aesthetic principles apply, remix and revisit as you see fit. Here you can see how the screen actually snaps in. And here's the CNC board. Again, it's a real simple little unit. It comes in a little kit, and you just snap everything together. Here again, you can see these wonderful connectors. They're really, really robust, and there are a lot of wires there, but you just have to count them in and screw them down. It's not, what is the term? Rocket surgery? Here's the voltage controller that will give you out both 5 volts and 12. And again, screw terminals for all of these things. A really nice system to work with. I've enjoyed it. So, moving forward, I'll see, this is, again, that same connector. All right, now here you see it working. Now you might be able to see it working here. It is currently stirring. Look at that thing. And just so you know, this isn't just stirring nothing. Both in this video and what you see here is actually manufacturing medicine, and you will watch me extract it at the end here. So it's not just a demo proof of concept. We've used this for many things, and it works great. So I'm excited. At the end, and what you'll see me do soon, is you'll end up with the inner jar filled with active pharmaceutical ingredient in a solvent of some sort, and then you pour it through a coffee filter, and then you let it dry. And it basically looks like this. It's a fairly simple thing. You dump it out, you let it drip for a while. Now, we're not gonna have time to let it dry and watch, but once it does, you can see there's this little powder that's left on the bottom, and then you peel it open, and there's your stuff. So anybody who says, chemistry is scary, or if this sort of makes you nervous, you maybe remember some weird person in high school who abused you with like orbital theory and, stoichiometric balancing. Like, yeah, if you wanted to pursue a career in chemistry, you might have to follow that. But if you just want to use chemistry, it's not so bad. So if you're trying to figure out a reaction procedure and you go into the chemical literature, it's difficult because it's not really a procedure. It's just, here's how I did it. So there's a lot of decoding. Again, it's not necessarily the only way to do it. It might be the easy way that somebody found. So it's highly subjective. Of course, it also has a bunch of jargon that if you don't have a degree in chemistry, might be pretty hard to deal with. And on top of that, you have to dig through the literature to find it. And one of the things that I'm super excited about is once more people start using this, if you say, hey, I figured out how to make XYZ on the microlab, and you build a file for it, you can just trade it. You can just torrent your drug of choice. I mean, shouldn't you be able to download everything? Why not medicine? So let's look at this wonderful system that's been built. This is hard. Let's look at the easy version. This is this wonderful GUI, and you may have seen this. This is our little captcha here. So select our pharmaceutical companies which have not settled for over 500 million US dollars for off-label promotion kickbacks. If there are none, click yeah. Okay. All right. Moving on. You can see there are two different types of steps here. One is the dark blue. That's something that's actually automated. That's something that the computer is doing. Then the turquoise, that is a human step. So of course, the machine can't load itself full of chemicals. It has to ask you to do that. But there's a touch screen and it will talk you through that procedure. It says at the beginning, do you have the proper ingredients? Do you have this much? Is it in the solution? Okay, load it into the proper syringe. Are you sure you're there? And then the hard part for a human, which is trying not to watch the water boil while something stirs for 18 hours and making sure that the temperature is just right, the computer takes care of. Again, it's a perfect division of labor the way most things should be. So you can see we're going to scroll through. This is the procedure for svaldi. This was the thing that we were talking about yesterday. And you can see there are plenty of automated tasks, and at the bottom there's some post-processing that has to happen that's done by the human. That's why you see a lot of the turquoise in a row. And on the right, you can see when a particular step is selected, it has parameters. And you can go through and say, do you want it to stir? Is it cooling or heating? What temperature do we bring it to? What degrees? And for how long? And it's just that easy to edit. Again, it also supports branching. This is a big deal because the machine is not going to know if things aren't working, but the machine can ask you to check. So let's say, and this is a fairly common thing in chemistry, something just doesn't dissolve, right? So you've stirred it in solvent for a long time. It will say, are there still particulates? And you can then tell it yes or no. And if it says yes, then it will continue to stir for you. And it says, come back in another 20 minutes and let's check again. So nice little linear choose your own adventure, and you can build branching processes. Again, one other thing about this that I am super excited about is that additionally, if you have some sort of chemistry that you want to do that maybe isn't so complicated and doesn't even require something as sophisticated as the microlab, this still supports it. If you just need something to talk you through a process and have some contingencies, make sure you check XYZ, you can still trade ideas this way. So when we figure things out, we can tell each other, and we don't even have to meet each other. We can all just post it and be friends. Because I think a lot of us remember having stuff like that when we learned other things, but somehow it's not out there for medicine and chemistry yet. But it should be. So, this is the moment when I was going to hit the HDMI switch. I'm going to instead go through, show you the next tool, and then at the end we're going to swap to the other machine and we'll show the things live. So the synthesis pathway, this is Chemhactica. This is a system that we started in 2018, I think. It's gone through several iterations. It's got a new kernel. It's much more efficient, and you can ask it whatever you want. So for those of you who have a particular chemical you'd like us to look up, this is what it's going to look like. We're going to pull up Wikipedia. We're going to scroll all the way to the bottom. We're going to go and look for the SMILES code, which is an open source system for encoding both molecules and chemical reactions into an ASCII string. You have to click on show and it pops up. You grab that, you copy, you paste it into Chemhactica, and it'll draw the molecule for you. In fact, at the Collective, we use this just for either generating smiles codes or drawing things. It's got all sorts of utility. And for those of you who are super chemistry geeks, you'll see that there are 8 other modules within this as well. Typically what happens, which I'm going to show you in a moment here, is that you will just ask it to say, what is the simplest way I can get from point A to point B? But there are so many parameters that you can tweak. You can say, do not do anything that has a controlled substance as a precursor, because those are hard to find. You can say, don't use any precursors that are too expensive. If you want to have safety parameters and say, don't use anything as a catalyst that's a heavy metal, you can do that as well. Additionally, it will hypothesize if you ask it nicely. But for the most part, it is not doing that. It's looking through the chemical literature, all of the chemical literature that's ever been published, and it's combinatorially looking for different pieces of the reaction that you're trying to create. So you click on perform one step, and that's basically shorthand for show me the easy way. And when it does that, it will pop up either one reaction or a series of reactions, and you can go in and ask it to evaluate. Now what you see here is that one box is in blue, that's your target. Those 2 green boxes, that indicates that those are commercially available and you can just buy them. It will come up with things that are not commercially available, and those boxes will be red. You can then click on those and say expand node, which means if I can't buy this, how do I make that thing? And if you've got something terribly complicated, you may have to work your way back a ways. That's the thing that says tree builder. It'll do all of that automatically in the background if you ask it. So when you click on the reaction, here you see the smiles code for the reaction come up, and it gives you a lot of parameters. You can then ask it to evaluate, and it will give you the solvents that you need, the temperature at which it should work, and again, how well it expects it to work. So you can get purity and yield guesses, which of course are dependent on conditions, but it'll give you a good guess. I got interviewed with a guy who told me this heartbreaking story about his childhood friend dying of, I believe it was multiple sclerosis at 25, because she had a very rare subtype, and the medicine for that particular subtype, because it was so rare, had been given orphan drug status, which gave it this extended patent length, and also allowed for the price point to be whatever they wanted. And it was priced at $850 a day. And she died. And he and I sat down, and I shared my screen with him, and we went on Chemhactica, and in a matter of minutes, he and I, neither of us chemists, figured out a way to manufacture it for $20 a day. It's that powerful of a tool. Now, that's not to say, of course, that there isn't some chemistry still to be done. You do need to figure some things out. But this gets a huge jump on it. You could potentially find a synthesis mechanism just with this and a good chemist, rather than having a giant team of them work for months. The recipe press is a brilliant piece of work. Chemhactica is a brilliant piece of work, but let me just talk about svaldi specifically. Here it is rendered in 2 dimensions. I'm sure you've seen this. For those of you who are chemistry phobic, do not let this bother you. I promise this is simple. Our chemists are brilliant and did the hard work. Here's what the reaction looks like. And the amazing part of this is that it is only one step. So pay attention. This will be very quick. It will only take a moment. Here's what you have. On the right, you will see this ring with fluorines. The fluorines and the oxygen will break off like this, and you get that little extra stick that wants to connect to an oxygen. And there's that lonely little oxygen on the other side, and they're going to make friends. And they do it like this. And for those of you with good short-term memories, you will see that this is indeed the molecule that we were trying to get at the beginning. A single step, and you can get this drug. You want to see it in 3 dimensions? Yeah. Here you go. Again, the fluorines are the green, the oxygens are the red. You're going to see this piece break off, and you're going to see this extra little stick and it wants to come around and a little smooch. And there's svaldi. Now, eventually, you're gonna have to make pills. They just passed a law that make owning a pill press a felony. Hilarious, because all you need is something that will press something. I've had people tell me that reloading devices can do this. A simple arbor press will do it too. Say you want a pill mold, you can print one out of resin. Then you take your active pharmaceutical ingredient, you tap it in, you fill it up, you put the plunger in, you press it down, and then you spray it with glitter. Why do you spray it with glitter? Well, to put it in the words of one of our chemists, if it doesn't sparkle, it's not my revolution. I know I've put this figure up many times, but it still horrifies me, no matter how many times I see it. This is a commercial svaldi pill. This is a $1,000 bill. Now, they're in circulation, not much, but they're around. You can find them. They're mostly collector's items, but you can get them. Grover Cleveland, everybody, $1,000. How ridiculous is this? Now, contrastingly, here's our little pill that we made for $3.50 worth of materials. So, here's a question. Which would you pick? Now, I happen to have one of these pills. What would you pick? The bill or the pill? So, who would take this collector's item? Yeah? All right, come up. Here. Now, these are actually worth more than $1,000 because they're so rare. There you go, yours to keep. Woo! Joke's on you though, it's counterfeit. So you're actually in violation of a whole bunch of laws right now because you took that from me. Contrastingly, this is not counterfeit, it's pirated. There's a difference. This doesn't try to look like something it's not. This does the exact same thing as the thing that it's trying to be. And it doesn't have to try. This is both chemically and isomorphically identical to anything that you would get in a pharmacy if you had the money. Now, I get this question a lot. Now, of course, the point of all of this is that you don't have to test it. The systems are designed so that all of the care and attention you can get on the front end, and then you don't have to. But we did anyway. Anybody out there who knows how to read a high-performance liquid chromatography readout will see that this is fucking amazing. That spike is perfect. There's only one thing in there. For those of you who don't read these, here's something a little more quantitative, and I will draw your attention to this number. That's the purity. Before you get too impressed, allow me to say, if you were to buy svaldi in the raw from a chemical supplier, you only get 98%. Again, for those of you who are astute with numbers, you will notice this is an order of magnitude more pure than what you would get if you bought it. Yeah. Where'd my goon go? I need another shot. Thank you, sir. Watch this. My team's watching and they're all freaking out right now because I didn't tell them I was going to do this. Woo! And I don't even have the hepatitis that I know of. All right, let's keep going. I have 5 minutes. Want to quote some other superheroes? You'll notice this. Now, this is the 4th time I'm mentioning this. And I mention this because this entire course of treatment can be made for $300 in raw materials. And I happen to have it right here. Now, who said they had a friend who was infected with hepatitis? There were a couple people. Right here? You, come up here. Keep your friend healthy. Keep them safe. Thank you so much. We should be doing this every day. I get this question a lot. I'm going to move on now. Again, if you don't differentiate between morality and legality, one of us is in the wrong conference. Again, none of our work scales up. This is worth noting because those of you who are like, wow, he does stuff super cheap. Maybe I could start a business. It won't work. I mean, go nuts, right? But you're going to be wasting it. Talk to a chemical engineer. Scaling chemistry is very difficult. When you do it on a small scale, it's much easier. And additionally, some people are like, oh, that's super exciting. How do I get one? You make it. We don't sell anything. We don't even sell merch. We have a merch page on our website showing you how you can make your own. You've all seen this stamp. This is when an authority figure tells you you're allowed. Now, some people decided this might look cute, but you will never see this on anything ever, because we are not an authority figure and we are not telling you what to think or what to do. The only thing that the Four Thieves Vinegar Collective will ever approve is you making your own decisions about your own health. And that we've already approved. So go on and do the thing. This is an American phrase, isn't it? Yeah. I'm gonna add another one from the same genre. And with this, I would like to address the feds out there. And some of the execs from pharmacy. I've spotted some of you during the day. And I'd like to say the following. I would rather be singing your praises. I would like it much better if you did your work properly so that our work became obsolete and we could go do something else. But until you do, if you would like to stop me, you will have to send assassins. Because so long as you stand between people and the medicines they need, due to your greed or your ignorance or your cowardice, I will fight you until I curse you with my dying breath. And when you kill me, it won't matter much. I'm just another human, like the thousands who die from your inaction every day. And the other members of Four Thieves will step in to continue the work. And the future members of Four Thieves that are probably sitting right next to you now will come to join them. And the ones far away we haven't even met yet, because we are fighting for nothing less than our lives. Woo! Help is not on the way. I will say this last. My fellow hackers, come join us. And we have one last tool that everyone can use. And you don't need to read anything about it, and you don't need to build anything. The next time a medical officer says you can't have what you need, look them in the eye and say, if you will not help me, I will make this myself. Because that's the truth. You can. Thank you so much. I'm going to start with looking at some of the drug requests. Somebody says, testosterone, please. Yeah, that's a hormone. Doable. Can we synthesize estradiol? I'm sensing a pattern. Okay. Vyvanse. Somebody here was nice enough to actually point out that there are some problems with this. Even after the patent has expired last year, I still have to pay $200 a month. Yeah, that sounds fucked. Let's maybe fix that. All right. This one I don't know. Mometasane furoate treats asthma and eczema. So I don't know. So one thing, yesterday somebody came up and asked me about monoclonal antibodies. I'm sure a lot of you have seen monoclonal antibodies in the news. They are this miracle thing. Unfortunately, they are too complicated for us to do. It's a macromolecule, they're gigantic. The way that you manufacture them is not the same as small molecule chemistry. A rough idea is if you can write it on a napkin, then you can probably do it over here. If it's big, not so much. So, can you get time release capsules for slow relapse meds? Yes. So that's in the compounding phase. There are plenty of ways to do that. Interestingly enough, I'm going to hazard a guess. This is somebody who wants Adderall XL, okay? Like just, maybe not. But in the case that you do, here is a trick. The way that Adderall XL is manufactured is that there are those tiny little spheres that are inside the capsule, and half of them are coated and half of them are not coated. It just means that some of those dissolve instantaneously and some of them don't. It is designed, not just practically, it is designed specifically only to be the same as taking half of one and then taking the other half 4 hours later. So, best time release system, look at your watch. Can you make insulin? Oh my God, isn't this a fucker of all times, man? So yeah, we're super angry about that one too. Insulin is something you have to sort of bioproduce. You can do it. What we're trying to do right now, actually as we speak, is replicate a system by which tobacco will manufacture insulin endogenously. Now you can't smoke it, but you can dip it. This has been demonstrated to work. We're just trying to steal it because it's not commercially available. But imagine, you just grow some tobacco in your backyard and insulin's free. Just like in that old tweet. Do any reactions require cooling? Yes, absolutely. Are you working on that? No, we already worked on it. So if you look at the machine, you'll see this thing under the foil. That's the cooling side. There are two things that circulate. There's a heating module and there's a cooling module. Often you have to keep things cool. If you have an exothermic reaction that's going to not be happy when it gets too hot, you have to keep it cool. So you will have a system that has either ice and water or ice and acetone or ice and isopropyl alcohol, and these will give you different set points that will be able to control your temperature. Could you make injectable medications like insulin or Humira? So this, again, is a question not so much of manufacturing of the actual molecule, but in terms of compounding. You can make injectable meds. You take that powder, you can put it into injectable form. If you do that, please be careful. If you're compounding things for injection, you have to practice sterile technique. Now, this is totally doable, okay? I don't want to scare anybody and say, don't do it. Be careful. No, be competent. You can learn sterile technique, but it is something that requires attention. Here's an example, right? Standard of practice for sterility training, your hands don't leave your line of sight or you've broken sterility. And here my hands haven't touched anything, and then you adjust your glasses and it's over. So a real easy lot of mistakes to make. Okay. Benzonatate. I'm gonna guess that's like a Valium type thing.
Cough suppressant.
Okay, yeah. I'm I'm not sure, but again, if it's a small molecule, probably doable. Somebody else is asking about Vyvanse. All right, cool. We got more stuff. What? All right, cool. A lot of people asking about Vyvanse. Oh, modafinil. If somebody just wants one now, just ask me. I think I have one in the pocket here somewhere. Okay, cool. So let's, so here, I will skip over here, and now that Wikipedia is making friends, let's look at Vyvanse.
There were like 8 people who asked about Vyvanse. I will give this a look. So the first thing we're gonna do is we're gonna hop over to Wikipedia. I'm gonna type it in, if I can spell it correctly, Vyvanse. I think that's it. Okay. And here we pop up with this molecule. It's an interesting looking one. We've got this benzene ring and a long chain with a couple of bits and pieces. So what we'll do here is we'll scroll down, and here in this right-hand column, we'll have the SMILES code. I'm gonna click show. I will grab this and I'll just copy it, and then we'll go over to Chemhactica. I'm gonna paste it in here, and there it pops up, and we'll say perform one step. And give it just a moment. There we go. Pop it over, one step. Let's see what pops up. So it's thinking a little bit, and there we have it. Okay, cool. So just so you all can see what's going on here, this blue box indicates our target that sits at the top. Each one of these is a different reaction that would give it. These two are in red boxes because it indicates that these precursors are not commercially available. However, if you did want to go down one of these roads, you can click on this and then ask it to expand a node. And this is sort of what it looks like. You see, it'll go through the same process that it did for our target, but for this. And then you see the tree builds out. So we won't use this reaction because there are easier ones. But if you did have to build something out, it's entirely doable. So let's give this a shot here. Looking at these three, these look very similar, but this one looks a little better. So I'm just going to click on number 2 here. And here we have a reaction. Here's the SMILES code for it. You can see that the SMILES codes work both for individual molecules as well as reactions. And here's the reaction itself. You can see it says it's very plausible. We're going to click evaluate reaction. It's going to pop open a new tab, and it'll show us the reaction here and the reagents necessary. There are a couple of different options here. And let's just say predict with conditions for this number 2. That looks pretty good. And it's going to think here for a little bit, and we'll see what it comes up with. And again, you have to wait a little bit just because we're doing this live. So bear with me a moment here. All right. So this is even better. This actually shows some citations in the chemical literature where it's actually been done. So you can click through here, and you would actually pull up the literature, and you'd be able to read how to synthesize that molecule. So for all 8 of you who are looking for Vyvanse, there's a way to do it. So sorry for the hard cut, but my team said I was doing too many things. Rest assured that it works very well with all the rest of the molecules we tested, and you can go on to synth.fourthievesvinegar.org and test this yourself whenever you want.
More questions. I am a software engineer and a med school dropout. How can I help contribute? Come say hi. Where are you? My God, come make friends. And like, I'm serious. I know that a lot of times people will come up on stages like this and say, no, we really want help from anybody. It doesn't matter your skill set, we can use the help. I'm not lying about that. Seriously, if you say I have no technical skills, I'm at Defcon because somebody dragged me and I don't know how to use my smartphone, but this seems cool. Seriously, come fucking say hi. We need all of you. No joke. Oh, there you are. Yes, especially you. All right. Do you have more business cards? All right. Yes. But this is the important thing. Yes, we have a bunch of business cards. If you want some, yeah, I'll pass them to you. But the big deal is not that we made business cards. The big deal is that you can make business cards. It's really, really easy. 6 dots on a piece of paper, let it dry and put it in a bag. There is not a person here who can't do that. So, you want a business card? Come get one. Please make a bunch with your friends. And if you have some anarchist collective or a bunch of geeky friends who are hanging out somewhere and you want, let me know. I'll come by and do a workshop and we can all just hang out at each other's houses and make abortion cards. Does that sound like a good plan? All right, call me. There was a second part to this question about purity and dose determining. Yeah, so the thing that's hard for most people who have seen modern chemistry to really grok is that it's entirely possible. Oh, we got Vyvanse. Oh, look at that. All right, cool. Is that you don't need all the fancy machinery. You know, you talk to people who work in chemistry and they talk about things like high performance liquid chromatography, gas chromatographs, NMRs. But wet chemistry has been done for hundreds and hundreds of years, way before there were electronic machines to check our work. There are plenty of ways to check for purity. The simplest one is called a Thiel tube. It's a little piece of glass that's a loop. And then you take a tiny little thing that looks like a miniature test tube from like a dollhouse. You stick it in, and then you start heating it. And then you'll see your powder turn from powder to liquid. And most things have sharp melting points. And if they melt at the temperature that you expect, you know that it works. And if it's off, you can do a little interpolation, just a little ratio. Don't get scared by the math, it's just a ratio, seriously. And you can calculate your purity. What CAD software does the team use? I haven't the foggiest idea. Somebody knows. Yeah? FreeCAD. Would it be different to get these equipment through airports, sending or across national or international borders? People typically don't give you shit. It's just a bunch of computer stuff. They might ask, but it's not that weird. International borders, slightly different thing. Is there a crowdsourced community for tackling a procedure as a group? Oh my fucking God, there should be. Now, here's the thing. There are 2 subreddits that are like super sleepy. I believe one's called like, they both have something like biohacking in the title, and there's not much going on there. What we would love to see happen is this start. Now, whoever wrote this question, please help us start this. I'm not kidding. This keeps me up at night because all of this stuff that we do, now, don't get me wrong, I am so grateful that all 300 of you are here, but if we are the only people who figure out how to do this, we fail. So please, let's figure out a way to talk about it. If somebody has a way to generate a subreddit or just create a thread where things are popping a little more, that would be spectacular. Any looking at Ozempic Wegovy? Fuck no. Shouldn't be taking that shit. Leave it for people who actually have diabetes. I'm sorry. Also, you don't want your retinas to detach. It's not a good look. I was anticipating this question. Are you still working on the mouth bacteria? How many people know what this is in reference to? Okay. Short answer. Yeah. It's done. We still need to change one last thing, but it functions properly. So it's going to be probably a couple of months before we actually release it. How do you plan to keep Chemhactica up to date? Well, that's a fair question. It does work within the ecosystem of open source software. We're sort of maintaining one fork. The heavy lifting was done by some other people. But there isn't a whole lot to update, really. It does crawl through a database called Reaxis. And anytime that you recompile, if you use that database, or I don't think you even have to recompile, you just have to point it to the updated version of Reaxis, and that should do it itself. With the rise of AI, would you utilize AI to make your device better? Do Do you think it would make it better? I mean, I know mansplaining as a service is real popular these days, but kind of a bad look. No, okay, but in all seriousness, we have been looking at trying to build some systems that will help you navigate the scientific literature, because taking technical jargon and boiling it down is something that the large language models seem to be good at, but we've been having trouble trying to get it to work because it makes shit up. Oh my goodness. All right. I know there is still more here. I got a 5-minute mark. Let me say one more thing before I step off stage here. If this work seems worthwhile to you, or interesting, or fun, come join us. We need your help. We need it now. Think for a moment, if I were to say, somebody's dying outside and you can help me save them, I just need you to come with me and help me, you'd do it. And if I say now that if you write me an email and we start working together, that we could save millions, why wouldn't you do that? And you don't even have to join us to join us. Just build your own. Figure out things that we didn't. Use it for procedures that we didn't think of. Make it better. Make it new. And teach people. There's no better thing that you can do as a technically adept person than to teach what you know to somebody who doesn't know it yet. We can make things so much better, all of us together. Please come chat with me after, write to us, or don't and just make it yourself. Thank you all so much for coming.
Rest in peace. Here's another warrior song. Rep this life to the fullest. Rest in peace. Rest in peace. Here's a toast to the dead for children with cancer.